So welcome everybody once again to the ELIXIR Training Club meeting. My name is Urmi. For those who don't know me, I work at Edinburgh Genomics and I'm also in one of the training coordinator group for ELIXIR-UK. So for today, we have got with us Tim Booth, and I'll give brief background about him. So we are very fortunate to have Tim with us, who is a bioinformatician and software developer at Edinburgh Genomics at Edinburgh University. So Tim's has developed quite a lot of pipelines in variety of things, but the focus for today is Snakemake. So Snakemake, for those who don't know, is a workflow engine and is a very powerful tool that help us with automation of workflows, especially in the field of high-throughput sequencing. But many users struggle to first understand how it works and how to begin working with it. So Tim has developed quite a lot of workflows in Snakemake, and this has given us ability to pre-process and analyze various types of sequencing data. And he has contributed to Snakemake developer community and the code of Snakemake itself. He has over 2 decades of experience in teaching Linux skills, programming, and data analysis. And his introductory Snakemake course, written to be part of the software carpentry extended curriculum, is now one of the most popular courses offered by Edinburgh Genomics, and it's attracting participants all over the world. Also, Tim has ongoing work with BioFAIR and WorkflowHub, which Tim will be talking about in his talk today. So please join me to welcome Tim, and without any further ado, I will pass over to Tim. Okay.
Perfect. Thank you for that lovely introduction, Urmi, and thank you for inviting me to talk today. Yes, I think that's we've had a very sort of succinct introduction to my topic of the talk, the Snakemake workflow system, and specifically how we're teaching the Snakemake workflow system. So I promise not to try to turn this into an interactive session, but it would be useful to know before I kick off, how many people here have some experience with using Snakemake at all? Maybe you could just raise a hand in the using the raise your hand facility if you have used Snakemake at any point. And I'm going to peer across at Urmi's screen because I can only see my slides at the moment. Is anyone reacting? A few hands have gone up. Okay, so we have a few people who've used Snakemake, but clearly quite a few who haven't. Okay, good. That's what I'd expected, but I just wanted to check. So in this talk today, I'll give you a very quick introduction to Snakemake. It takes us 3 days to teach it on our course, so you'll get the 5-minute version of what Snakemake is. I'll talk about our Snakemake training program, which has been going on for several years, but seems to become more popular as the years go on, and give some more detail as to what Urmi outlined in the introduction. And then I'll talk about the latest part of my work with some funding from the BioFAIR initiative, how we make workflows fair, that is, how we make them reusable, shareable, and not just something that you run on your own data and then forget about. Okay, so Snakemake itself, it's a bit of software that's been around for quite a few years now. The original release was in April of 2012, and it was the work of this guy here, Johannes Koester, who is now has a research team in Essen in Germany, but at the time when he started to come up with Snakemake, he was doing his PhD, and like many programmers, was not satisfied with the current ways that you could orchestrate analyses for the bioinformatics he wanted to do. There was a program that kind of did what he needed, which was an old thing called Unix Make. Now, Make is still used by programmers quite extensively. It's designed to help you build source code into executable programs, and actually a lot of bioinformaticians had started trying to use this, but there are many limitations with Make. So the feeling was that if you put the core ideas of the old Make software together with a newer thing written in Python, then you get Snakemake. So Python-based software, hence the snake. And this very rapidly took off. People appreciated the utility of this software. And nowadays, it's gone from a one-man project to an increasingly popular and really core bioinformatics tool. It's now on release 8.28, and there's a whole community of software developers contributing to this open source tool. And it's compatible with Linux, Mac, and Windows, although there's not many instances where you'd really want to do serious bioinformatics on Windows, but nevertheless, it's a very flexible piece of software, well supported, and as I say, continues to be developed by a large team of enthusiastic people. So if we just look at what it means to write a Snakemake workflow, this is a very simple workflow, and we'll not talk about the whole detail of this thing, because I'll just point out a few key features. Now, can you see my cursor? Yes, you can. I'm just peering across Toby's screen. So the first thing is that workflows in Snakemake are written as text files, programming files. So this isn't a point and click workflow system like you would get with Galaxy. This is basically a superset of Python, and anyone who's programmed any Python will recognize the distinctive style with the colons and the indents of the lines. But in the Snakemake language, rather than writing a set of machine instructions to be run from bottom to top, what you actually do is define a set of rules where each rule encapsulates one step of the analysis. And then Snakemake will put the rules together into a work plan, which it will execute. So we see here this kind of very trivial example. This contrived example has two rules. One's called rule hello, and one's called rule make names. And they're just going to do some text manipulation. And the actual manipulation, the processing, is done by programs that you would normally just run straight off the Linux command line. So here we're using the sed program, which is something that bioinformaticians might quite typically use for basic text file processing. This step here, this hello rule, is going to invoke sed to do its processing. And then the second rule actually uses a chunk of Python. So rather than using a shell command, we have actual Python code within the snake file. And when Snakemake goes to run this rule, it will run the Python code. So if we run this sample snake file, typical output that you see on your in your terminal when you run Snakemake is these yellow messages telling you that it's making a DAG of jobs. It's building a plan of what it's going to do, and it gives you a little summary of which rules are going to be run, and then we'll start printing the output of the commands, and this will then scroll down till you either get a red error message because something went wrong, or hopefully you get to the end and it will have finished and your result has been created. Now, because the rules are arranged into a kind of work plan, a DAG, as it's known, you can actually get Snakemake to show you automatically the DAG that it's built. So for this simple workflow, we have 3 instances of the make names job that are running, and all of those are feeding into a job that just runs sed and combines everything into a single file. And if you run this workflow, you see you just get this little text file that has a bunch of names in it. But that's really the core of what Snakemake does. It has a set of rules, it builds them into a DAG, a work plan, and then when it runs the work plan, it's running shell commands or Python commands, or indeed R scripts or other programs in order to do a bunch of manipulations until you get a final result. This is very, very applicable to all sorts of bioinformatics analysis. Actually, it's applicable to a lot of different types of data analysis that you might want to do. So a very generally useful program. And with Snakemake, you can build really quite complex workflows, and the code does get complicated, but it doesn't become unmanageable. So This kind of spaghetti that's currently on my screen represents a real workflow that was actually written and it is actually, as far as I'm aware, still in use. If you tried to write this using regular Python or shell scripting, you would have a mess of unmaintainable, unreliable code. But using a workflow manager like Snakemake actually allows you to structure these kinds of very involved multi-stage workflows in a way that becomes tractable. And that's just one of the advantages of using Snakemake, but it's the main sell, I would say. So that's talked about Snakemake itself. I started using Snakemake when I joined Edinburgh Genomics, which was way back in 2016. So even then, Snakemake was quite young, but it immediately proved to be very, very useful. And we started using it for lots of things internal to the facility. So it became clear that this was something that other people would want to learn about. And there weren't that many options for Snakemake training. I think at the time, the original author, Johannes, was doing some courses and there was some online tutorial material. But Edinburgh Genomics, we wrote our original Snakemake course and taught that back in 2019. In 2020, the Ed program sent some funding our way, but also funded some courses to be taught, but also gave us the opportunity to rewrite the training material. The original idea was just to reformat it, but the way that Carpentries encourages you to write teaching material is in a kind of way that is geared to the needs of learners and geared to the needs of teaching technology, and especially geared to the idea that you write reusable training material. So not just something that you yourself can teach, but something that you can hand over to anyone else with some knowledge of Snakemake, and they can teach the same material. So this the modern Snakemake course, the version that was written as a carpentry extended curriculum lessons, was taught 6 times within the Ed program, and even within that program, between those 6 classes, there were 3 lead tutors. So that's testament to the idea that this teaching material really is reusable and different people can pick it up and teach it. Since the end of the Ed specific program, Edinburgh Genomics has been teaching around 2 workshops per year based on the same teaching material, and it continues to be very popular. And in particular, all our courses, I would say, attract people from around the world, but for the Snakemake courses, we seem to particularly get a broad range of people from different countries and different institutions, and also from quite a few people from outside of bioinformatics who are interested in Snakemake. So it's a really interesting one to be teaching, not just for the material, but also for the people who get on the courses. For the way we teach the courses, all but one of them have been delivered online. But however we deliver them online or in person, we have a learning environment that involves giving every user a Linux virtual machine and virtual desktop that they can work on. And this means that they have all the software pre-configured and they have everything they need to learn from the software and Snakemake itself to a graphical editor and a way to view things like the pictures of the DAG and the book that they're working from, all on the same environment. So while Snakemake is very flexible and can be installed onto pretty much any machine, expecting learners to have all the software they need for the lessons on their own, say, laptop is just unrealistic. So you need some kind of controlled teaching environment. And as I say, we have these remote desktops that run on the cloud, which have worked really well for us. Work well for online courses and in-person courses. So I will say that in terms of the teaching material, we're not the only way to learn Snakemake, but the Carpentries course that we're teaching at the moment, I think, is the only one that's really aimed at biologists rather than being aimed at techies. The official Snakemake tutorial is really good, but it's kind of geared towards programmers. and other material that you can find online doesn't really go into the same depth that we're able to go into on this 3-day intensive course. So that's what we've got set up for our Snakemake teaching. Excuse me. And as I say, we've been running that successfully for a good few years. Now, Snakemake is a technology that can never really exist in isolation. I think more than anything else we teach, it's something that integrates other technologies. So just planning to learn Snakemake in isolation isn't going to work. You need to know about things like how to effectively use the Linux command line, some of the more advanced things that you need to know for shell scripting also play a part in Snakemake. It does help to know a language like Python or R, although it's not necessary to know Python. You definitely want to know about Bioconda, and then ways to install different applications and manage your software environment. But also we want to think about ways that we can share workflows. And this is this sort of bottom left-hand corner of the slide is where we're going with this at the moment, because it brings us on to, I think I'm reasonably good on time here, brings us on to the work that's happening at the moment to look at what we can do as trainers to make workflows shareable. So the context here is there's a big effort. It is a UK funded thing called BioFAIR, but we're by no means just planning to build tools for UK users. This is something that everyone should be able to get involved with and make use of. And BioFAIR is based around sharing data, but also sharing methods, and for that matter, sharing training materials according to the FAIR principles. Hopefully you all know what these are, but the FAIR principles for data sharing are that it should be findable, accessible, interoperable, and reusable. And in terms of what we have for workflows, I'd say that findability and accessibility may not be solved problems, but they're certainly problems where the solution is obvious, in that we have repositories like WorkflowHub, which is the ELIXIR kind of what's the technical term for it? The ELIXIR, well, key repository for workflows. There's also things like the Snakemake workflow catalog, which is a place you can specifically go to find Snakemake workflows. And then Zenodo, the famous data sharing site, also has a workflow section. So knowing where to put your workflows so that they are preserved and accessible is kind of dealt with by these. But where we can really make a difference as trainers is in the reusable part, the final R of FAIR. And for a workflow to be reusable, there's really two goals we're looking at. The first is, can I repeat the analysis that was done with the workflow? If the workflow was written to analyze a specific data set, can I retrieve the raw data and repeat that analysis and kind of verify the original analysis? So a sort of provenance thing. But also, can I repurpose the workflow? Can I make use of it for my own data? And in the world of sharing, you've got a kind of continuum from sort of good enough sharing to actual best practice. So the kind of minimum that we'd expect nowadays for published work that involves a substantial data analysis is that you chuck your code onto one of these repositories, you get your DOI, but the code stays online. So it's a code dump. It's not pretty, but it at least preserves the analysis that you did. On the other hand, we have this kind of best practice idea where everything's neat and tidy, it's portable, it's fully reusable, it's documented, reviewed, and even supported, so that people coming to use your workflow in 2 years, 3 years will want to use newer versions of tools, they'll want fixes for any bugs they find, etc., etc. And most workflows are never going to get to this gold standard. There's projects like NF Core, which want to curate workflows at this gold standard. But for most people, they just want to be somewhere along that continuum and find the kind of appropriate amount of work to put in to share the workflow that kind of gives us something that we can potentially reuse. So from a teaching approach, There's reams and reams of information out there. There's gold standards, there's to-do lists, there's checklists. But what do we actually need to teach people who really have probably only just learned about Snakemake, maybe have just written their first Snakemake workflow that actually does a hands-on data analysis for their own data? They're not confident programmers. What do they need to know to share their workflows in a way that just sort of gives maximum effectiveness without trying to aspire to some unachievable gold standard? So as part of our recent training, our upcoming Snakemake courses will include an extra day developed as part of the BioFAIR work tackling these issues. And what we're going to tell people is, firstly, that testing is key. I think many people who write software in bioinformatics, be it workflows or anything else, don't really appreciate the importance of testing and sample data sets. So that's the kind of start of this new material. And then as in the day on the course, they're going to take a small sample workflow that was developed earlier in the week and actually submit it to WorkflowHub. We can actually do this as a hands-on because WorkflowHub runs a development instance where we can actually send our workflows, and they don't care if we have 20 people sending the same kind of test workflow to Dev WorkflowHub. They're quite happy with that. So we can actually do an upload, and we can show as we do that, why things like the consistency guidelines, the file naming conventions, the reusability guidelines, the licensing, etc., the integration with the integration of WorkflowHub with Git actually make sense in context rather than just bombarding them with this kind of flow of information, specifications, etc., etc. I'm now at 2:25, and I think we might still be able to squeeze in some questions. So much as I'd like to kind of keep talking on this, I'll say that I hope maybe if some of you are interested or know anyone who might be interested in Snakemake and sharing workflows in general, we do still have places on our March course, so you could be one of these happy people learning about Snakemake. But I think, given the time, I'll wrap up there. Thank all these people who've contributed in various ways to the whole project. And do we have a few minutes for questions still? Thank you very much.